Hi everyone, it's Mr. Gasman here to walk us through today's lesson on the periodic table. So today we're going to be looking at the periodic table and determining the properties of atoms based on their position on the periodic table. And then we're also going to look at three categories of elements: the metals, nonmetals, and metalloids, and some of the characteristics that go along with those. So here we go. So just a quick refresher on element symbols that early on, people like Berzelius introduced a lot of the elements based on their Latin names. For example, ferrous is the Latin name for iron, and gold, the Latin name started with AU. So a lot of our elements, especially the early discovered elements, were given symbols like FeAu that were based on the Latin names. And later on, we started using elements and element symbols that were given off of the first or second letter of their English name. For example, helium, He, and lithium, Li, are examples of this method. So these are what appear on the periodic table. Early on, the periodic table was kind of a mess. There wasn't a whole lot of stuff going on with it that was organized, and we had to go through a long process, and some people actually did a really great job of organizing it. And essentially, they filled in a periodic table with missing pieces that were then later filled by atoms that people didn't even know existed yet. So this is an example of the original periodic table, and this is really messy and it's really difficult to understand. So it's really great that they came up with the modern periodic table. It consists of rows and columns, and each thing is numbered. It does work out very nicely. They go in order, and you're going to see today that there are some characteristics that go along with each one. So the organization of the periodic table is into 18 vertical columns that we call groups. The main groups are what we will be studying here in ninth grade physical science, and they are listed there in the color. The white are what we call the transition groups. They have a little more, let's say, complications with them. They are a little bit more difficult to categorize, and they have some funky interactions. So we're really going to focus on the main groups, which are groups 1, 2, 13, 14, 15, 16, 17, and 18. But there are 18 total groups. And then the periodic table wouldn't be complete without periods. Periods are the side-to-side horizontal rows, all right? And there are 7 of them. So hydrogen and helium are the only two in period 1. Then we start the next row with period 2, 3, 4, 5, 6, 7, all the way down. Now, you'll notice very quickly that there are certain characteristics of all group 1 elements and all row 1 elements or period 1 elements. They all have certain characteristics and they're different, but it does make it very easy to classify, and you'll be able to pick up on different pieces of that. So when we look at this, all group 1 elements will have one. Let me go back actually. Let's take a look at this. All group 1 elements will have 1 valence electron. 2 will have 2 valence electrons. If we hop all the way over to 13, it'll be 3 valence electrons. 14 has 4 valence electrons. 15 has 5. 16 has 6 valence electrons. 17 has 7 valence electrons. And then 18 has 8, or in the case of helium, 2. They actually influence their properties and their different interactions immensely. And then if we look at the periods, so all of the elements in period 1 have 1 valence electron shell. They only have 1 orbital ring. They only have 1 energy level. Helium and hydrogen only have 2 electrons, so they only fill the first level. Period 2, all of these have 2. They fill the first 2, and then they start on the second. The third period, they have 3. So they fill the first 2, start filling up the third energy level. 4, 5, 6, 7, they all end up adding 1 more energy level to them. And that's how the periodic table is organized, by groups and periods that are influenced by the amount of valence electrons that they have, and that corresponds with the groups, and the periods correspond with the electron energy levels. So when we break that into a couple pieces, the organization of the periodic table breaks down into three types of elements. There are metals, nonmetals, and metalloids, and each one has a little bit different characteristic. So the first one here in yellow, highlighted in yellow as you see here, are the metals, and metals make up the majority of elements. Most of the atoms and elements on the periodic table of elements are metals. Well, what is a metal? Well, they have common characteristics. Most of them are shiny, and most of them are pretty good conductors of electricity. Now, that's not exactly true about all of them, but that is kind of the common theme among the metals. Example, mercury down here is a liquid. That's different than the others. So there are a few that are a little bit different than the others, but the metals are typically shiny and good conductors of electricity. Copper wire is a good example. Copper wire is shiny and it is a very good conductor of electricity. The nonmetals then are kind of the opposite. The nonmetals are found here with hydrogen, and then on the right side of the periodic table, they are kind of the opposite then. They are all different types. There are some solids, there are some liquids, and there are some gases that are found in nature, or at most commonly. They are typically poor conductors of electricity. So these are usually not shiny in their solid state, and they do not pass along electricity well. So they don't let electricity flow through them. The third type then is a metalloid. You've probably already guessed that a metalloid is something kind of in the middle, and you see it there in pink on the periodic table, and it forms a staircase here between the metals and the nonmetals. And they have properties of both metals and nonmetals. So they form that stairway, so some of them are good conductors of electricity, some of them are shiny, but some of them are also not shiny, some of them are also not good conductors of electricity. And that influences that. Boron, silicon, germanium, arsenic, and some of these other ones like polonium are really great examples of metalloids. And as you see on the periodic table, all of them are found as solids at room temperature. So again, another big picture. For my students, we'll be using this a lot. It's one of my favorite things to do is have you guys color it, but unfortunately we won't be able to do that this year. So we'll get into this a little bit differently here in our meeting today. So again, just to recap all the learning targets from today, we wanted to be able to determine the properties of an atom based on its position on the periodic table. So all atoms in group 1 have 1 valence electron, 2 have 2 valence electrons, 13, 14, 15, 16, they all have that last number. So 13 has 3, 14 has 4. That's how many valence electrons, and that's going to influence how reactive they are. If it has 7 or 1 valence electron, those atoms are very reactive. They like to react more commonly than things that have 3, 4, or 5 valence electrons. And we can determine that based on the periodic table. You can also determine what energy level the electrons will fill based on the period that they are found in. So group determines valence electrons, and periods determine how many energy levels electrons will fill. And then you can list the basic properties of metals, nonmetals, and metalloids, like metals being shiny and good conductors of electricity most often, and nonmetals being the opposite, where they're not so super shiny and they're not great conductors of electricity. And metalloids, as the name kind of shows us, is somewhere in between, that have properties of both. Let Mr. Oleg or I know if you have any questions. Have a fantastic day, everybody.